Welcome to the XFO Intelligence Podcast, the Cosmic Series. Imagine learning that the city you live in is part of a single, contiguous nation that spans the entire globe. An impossibility, right? Now, let's apply that feeling to the cosmos. What if I told you that our home, the Milky Way galaxy, exists in a place that, well, according to our best science, it simply should not exist? That our entire cosmic neighborhood is part of a structure so vast, so impossibly enormous, that it challenges the very foundations of modern cosmology. You see, for decades, our map of the universe has been drawn using this powerful framework. It's known as the Lambda Cold Dark Matter model, or LCDM. And this model has been a triumph, really. It explains the faint afterglow of the Big Bang, the strange rotation of galaxies, and the large-scale distribution of matter. But this model, it also sets a sort of cosmic speed limit on construction. It predicts that given the 13.8 billion year age of the universe and, the constant outward push of dark energy, the largest stable structures, these great walls and filaments of galaxies, they should be no bigger than about 1.2 billion light-years across. Anything larger simply hasn't had enough time to form. Recent astronomical discoveries have shattered that limit. Multiple independent surveys confirm it. Our Milky Way is embedded within a cosmic formation that is many times larger than this theoretical maximum. It is, in the words of the scientists who found it, an impossible structure. And it's not alone. This discovery, it joins other anomalies, like the Big Ring on the sky, another titanic structure that just defies explanation. It's becoming clear this isn't some simple measurement error. No, this is a systemic issue. The universe, on its grandest scales, is not behaving the way our rulebook says it should. So where does this leave us? Well, it places us at a thrilling, really fundamental crossroads in our quest to understand reality. This single massive anomaly is forcing a complete reevaluation of, well, everything. One of the most profound new ideas emerging from the data is a total shift in perspective. We may need to stop thinking of the universe as just, a random collection of matter pulled together by gravity, and start seeing it as a complex, self-organizing network. This is the core of an emerging field called network cosmology. Think of the cosmic web, that vast filigree pattern of galaxies and dark matter. Think of it as an optimized transportation grid. The glowing filaments are not random. They're more like cosmic highways, forming the most efficient routes between the dense galactic clusters, which act as cosmic cities. The vast empty voids in between, they aren't just nothingness. Their very shape appears to be configured to make the universe's expansion more efficient. In this view, the universe is a system constantly seeking the most energy-efficient configuration, not unlike a river system carving the most efficient path to the sea. Another radical idea that's gaining traction is that dark energy itself might not be the smooth, uniform force we've always assumed. What if instead there is a dark energy landscape with hills and valleys? Even small local variations in its density could create these cosmic pockets where its repulsive force is weaker, allowing gravity the upper hand to build these impossibly large structures over billions of years. And perhaps the most mind-bending concept is what some are calling a cosmic memory effect. The idea is that the quantum fluctuations from the very, very first moments of the universe created a persistent underlying pattern, a sort of fossil network that has guided the formation of all structure ever since. This would explain why these superstructures appear far more mature and organized than they should be. The blueprint, in a sense, was there from the very beginning. The implications are staggering. It means the cosmological principle, that foundational idea that the universe is uniform and homogeneous on the largest scales, it may need a major revision. It opens the door to new physics, hinting that we might be seeing the effects of quantum gravity playing out on a cosmic stage. This isn't just a theoretical puzzle, it is a paradigm shift. We are moving from a purely reductionist view of the cosmos to one that, well, embraces complexity science. The universe may not be a simple machine, but a vast, adaptive, evolving system. And as we stand here at this cosmological crossroads, we have to ask a new question. Perhaps our galaxy's position within this impossible structure isn't an anomaly at all. Perhaps, in a universe governed by principles of optimization and complexity, this is exactly what we should expect to find. This brings us to a question we'd like you to reflect on. What do you believe about the fundamental nature of our universe? Do you see it as the grand outcome of random chance and unchanging physical laws, or as something more akin to a self-organizing, intricate network? And more importantly, what in your experience of the world makes you feel that way? Thank you for joining us on the XFO Intelligence Podcast. If you found this journey to the edge of our understanding as fascinating as we do, please like, share, and subscribe to our channel for more deep dives into the hidden intelligence of the universe.